An automobile tire is filled to a gauge pressure of 200 kilopascals at 10 degrees Celsius. After a 100-kilometer drive, the temperature in the tire rises to 40 degrees Celsius. What's the gauge pressure in the tire now? So we're looking at the pressure and temperature at two different points in time. So we can start with the combined gas law, which was the P1 V1 over T1 equals P2 V2 over T2. Since we're going to assume that the volume of the tire is staying fixed, so that V1 equals V2, we can just cancel those out of the equation, and we're left with P1 over T1 equals P2 over T2, which is a equation called the Gay-Lussac's law. And we want to solve this for the pressure at the later point in time. So we're looking to find the P2. So rearrange the equation. So P2 is equal to P1 T2 over T1. Now the first pressure, you cannot just write it as the 200 kilopascals because that is the gauge pressure. So we're going to have to convert that into the atmospheric pressure into absolute pressure by adding on the atmospheric pressure. So the gauge pressure of 200 kPa is the same as saying 200,000 pascals, or 2 times 10 to the 5th pascals. To get the absolute pressure, we have to add on the atmospheric pressure, which is 1 times 10 to the 5th pascals. So that gives an absolute pressure of 3 times 10 to the 5th pascals. So this is the absolute pressure, which is going to be the P1. So I can write that in the equation. 3 times 10 to the 5th times, and now we got to put the temperatures in, but those are given in degrees Celsius, and in order to use the ideal gas law and the combined gas law, the temperatures have to be in kelvins. So add 273 to each of those. The T2, which is 40, when you add 273 to that, you get 313, and T1, which is 10, when you add the 273, you get 283. That gives you a final absolute pressure of 3.32 times 10 to the 5th pascals. So this, too, is an absolute pressure for P2. So to get the gauge pressure, we want to subtract off the atmospheric pressure of 1 times 10 to the 5th pascals, which leaves you with 2.32 times 10 to the 5th pascals for the gauge pressure inside the tire.